Hey you guys, here's 16, just really quickly. Things that you need to find in here, and I don't know, it's been a while since we've looked at this, so let me be explicit on here. This formula is, I'm identifying in red here in this differential equation, this logistic differential equation. That first value, 0.08, that's k. So the formula is k times p, the population, observed population, minus k divided by L times p squared. And there's a couple other ways you can, some people factor out the k and write it in a different form, and it's all the same thing. But this one, if you know that negative 0.00004 is k divided by L, over here to the right, I'm going to put it in highlight in blue, I've calculated out what L is using those values here. Okay, so there's L, should be 2000, k then is 0.08. That gets you through the first two. So now I've got k is 0.08, and you've got L is 2000. That's the carrying capacity. Saturation, there's a couple other words for it. K and carrying capacity are A, right? And then B, the initial population is P of 0 equals 10 horses. Find a formula for the population in terms of T. Now we just need the logistic function altogether, and that's pretty easy. So here's that function here, down at the bottom. What we'll do is we'll use that initial condition to find A. That's a constant relative to the population that we're talking about. So is K. There's some various capacity issues in here. So we're going to do, let's see, 10 horses for our initial population. L is 2000 we got from above. And 1 plus A, the part we're going to solve for, e to the negative 0.08. T is 0 for this initial condition, and what that allows us to do is, because e to the 0 is 1, that cancels, and so we're just solving this 10 equals 2000 over 1 plus a. And if you remember a little algebra trick, you can swap these two out, that denominator and that whole number. We can just swap those out and set that equal, so we get a nicer equation which looks like the following. So here's what we get in that situation. Do no cancel 0 at the end there, so 1 plus a equals 200, so a equals 199. So that completes our formula. You can go ahead and insert that into part B above. And then at number C, how long will it take for the horse population to reach 350? Then you're going to take this brand new equation we have here. So I'm going to do this in a different color, let's say blue, just off to the side. Then we're saying, all right, I want to reach 350, and from the given initial conditions of, a limiting capacity of 2,000, and 1 plus our brand new a of 199, a to the negative 0.08 t. Now we're in the business of just doing some nice solving to get to that. Sorry, I forgot my e that goes in there with it. Wait a second, that is an e, not a. There. Now we're better. A lot of letters, huh? And then we're going to solve this for t. First thing I'm going to do is that same swapping the denominator under the 2000 with the 350. Okay, so that's what you see now. Oh, sorry, I erased all that other stuff. Feel free to back up if you need it. And then, we can do a little bit of arithmetic. 2,000 divided by 350, we'll subtract the 1. We'll divide away the 199. And then what we'll end up doing is take the log of both sides, and we should be on the home stretch. So by my calculations, those things I just mentioned get me to 0.0237. That e function equal to that. So now here's where we can take the log of both sides, and then hopefully we end up with a nice consistent value of t given the context. And according to my calculations here, if I took the log of both sides, then you see the result here. Then you take and divide the log of 0.0237 by, and that's rounded. I kept it all in my calculator, so I didn't round at all as I was going through. I just kept it running in the calculator, and then divided by negative 0.08 and got 46.78 on. It says round to the nearest 0.1, so I went 46.8 years. And do let me know if some error comes up. I'm doing this kind of quickly with some calculating on the side, so if something funny comes up, do let me know. Could definitely happen. Good luck out there. Keep emailing.